Good afternoon. Today I'm going to show you this fully 3D printed bodied electric guitar. So unlike the previous two I've shown you, this one does not have any steel or carbon fiber reinforcement in it, and yet it's still rigid enough. And I'll show you the recipe I used to achieve that. But before we go and look at the 3D printing, let's talk about the guitar tone I'm using here. So first let me stomp over to this. Okay, so as you might have noticed, this guitar has no controls at all. What I've done is I've wired the bridge pickup to the tip of a stereo output socket and the neck pickup to the ring of a stereo output socket. So I still have neck and bridge pickups separately available, but I have to do all of that stuff in a guitar processor rather than on the guitar itself. So here is the neck part of the sound that you heard combined in the intro. So that is neck pickup through a clean amp, my usual cabinet IR, and then through a compressor, because in order to blend with the distorted sound I'm using on the bridge pickup, it needed to have a compressor put on it. What I actually like a lot more is that clean sound without the compressor and with some modulation effects on. I think it's pretty nice. See what you think. What I particularly like about this tone is it's very responsive to where I play. So if I change where I'm picking, due to how I'm monitoring this, I can't hear exactly what it's going to sound like to you as I'm playing, which is a little bit annoying, but I'll muddle through. Anyway, if I stick the compressor back on, that will help me hear what I'm doing, and let's see if that touch responsiveness is still there. Versus, it is still there. Because I don't have a tone control on here, I am running that through a low pass filter first. If I turn that off, here's what it sounds like. So all of that's neck pickup stuff. Let me show you now what bridge pickup on its own through the distorted amplifier sounds like. I don't really like that aspect of it. I don't like that it doesn't respond to my picking technique. I don't like to usually think of myself as an artist, but as an artist, as a guitarist, I'm trying to express myself. The medium I've got is, the different techniques I can use to try and make different sounds. And when I'm going through an amp that just squashes all of that into sounding the same no matter what I do almost, that's where the high gain sound gets a bit unsatisfying for me. But to fit in with sometimes you do want that tonality, but I'd like to have that tonality and the expressiveness at the same time. So that's why the preset you heard earlier exists. It's to blend this bridge sound, which is all high end, gritty, and very it completely ignores the technique. And I'll play some chords in a moment, and you'll hear that it pretty much destroys those. Any chord will sound the same. So let me play a E major, G major, A major, A minor, E minor. Particularly the difference between A major and minor, barely anything there, and between E major and minor, again, nearly the same as each other, which doesn't help your kind of feeling of harmonic movement. So what if I want that the high gain tone, but I also want to do chord progressions and have them mean something? Well, if I stick my clean tone blended back in, let's see what we get. So I'll do E major and minor, and then A major and minor. So if I do a sort of fairly normal pop chord progression, you can hear we've gone in the cycle there, but you still got that aggressive tone, and I can blend those two levels to get the sound I'm after. They're processed independently. And so when I edit this, you won't necessarily hear exactly what I heard in the room. You'll hear what I think I want you to hear, if you see what I mean. That's it for today as far as the electronics in here goes. I'll do a future video, I think, on guitar pickup theory and phase cancellation and that kind of stuff. And this guitar was useful to me in exploring that topic in the practical domain. I don't make these guitars and then show you day of printing it or anything. This has existed as a thing for about a month, and it has been tuned up as a guitar for about that length of time, and it is now a stable instrument. So this, when I say it's fine to print a guitar out of PLA, I mean this is now as stable as one of my wood guitars in the same kind of time frame. So anyway, let me show you the recipe. This is my 3D printing slicing software, and this is the core part of that guitar. So the part in the middle with which the wings screw onto. So let me just show you so we've got, in case you've not seen a slicer before, this one, we've got prepare here, which is where we set the parameters, and preview is going to show us what the sliced thing looks like, and slicing is the term we use for but basically it's get printed as a stack of layers of plastic, and so it makes slices through the model and works out how to print each of those slices. That hence we call this a slicer. Anyway, so I have ironing turned on is the only change I made to the quality tab, and that's because I wanted it to be a smooth surface on the backside of the guitar, because that's where it's up against my body, and if that's smoother it's more pleasant to hold. It's not particularly important, I don't think, to have ironing on. This is where the excitement is in terms of the recipe, I think. So the infill pattern is to use is aligned rectilinear, and then you have to change the direction so that the infill is going to travel in this direction. So you have solid lines from the neck pocket down to the back end of the guitar. We don't need anything this way, we just need everything this way. Ooh, crikey, don't want to do that. As you see, this barely fits on my printer's build plate. So yeah, we are at the limits of what it can do, or close to them. And the other important change I made is to turn on multi-line fill. So instead of printing one line of plastic on each of those lines, it prints 3 side by side. And the reason to do that is those 3 will provide some mutual support to each other and create a stiffer structure internally, more resistant to various modes of bending that plastic will otherwise engage in, much more resistant than the same amount of plastic, but in one line at a time. I was gonna, if this didn't work, I would have cranked it up to 5 or 6 or something and tried again, but 3 has worked. Exceeded my previous expectations for it. With 1, I don't think it can do it. With I did not actually try 2. I thought it was not enough of a change to make a difference. So anyway, but 25% infill, 3 multi-lines, and aligned infill with the direction that I need it has been a good recipe. So let me show you what that looks like when we slice it. And okay, so I'm now going to go to the line type tab. I will get rid of, I don't need that visualization, don't particularly need that, don't need that, don't need that. Yeah, don't want to see the support stuff. So I'm printing it this way up because these 3 surfaces are all at the same level, and they're the only 3 that need support if I print the part this way up, which means I can just print, I only need to do 1 transition layer to change from normal material to support material and back, which means there's not a lot of material changes, which is, material changes are make the print take longer, and I just wanted it to be done more quickly. There's also like a bit of a potentially a strength compromise around the points where you've got a material change. So I'm using PLA for the body and support for PLA material for the support material, and those should be compatible without a strength degradation, but there's a chance that after we've used the support for PLA, there's some of that still in the mix in the nozzle when it's printing the next layer up that will create a weaker layer there than if it were, just PLA the whole way up. So I want to minimize that for both of those reasons, and this print orientation is designed to do that. Because if I printed it with the back of the guitar on the print bed, I would need to support all the way up this gradient here, which is the neck pocket hand relief, as well as inside this control cavity. Anyway, So let's turn off the walls and the top surface and the ironing. There we go. So that's just the infill. This is the spars. If I turned off everything except spars infill, that would probably be even more sensible, wouldn't it? So I've only got sparse infill here. This is the infill pattern on its own now. And so you can see that it's all lined up in along the axis of the guitar, and that is critical to providing enough anti-bending rigidity. So because all of those plastic beams will be resisting that. They're all oriented like this, and the bending forces, we're trying to bend it like that. Now, because it's a very tall beam and now relatively wide, it becomes very effective at resisting that bending motion. If we oriented the infill at 90 degrees to that, all those plates would be sort of parallel to each other, and the bending force would just be trying to push them close together, which they won't resist at all because there would be just air in there. So that's why that wouldn't work. And if we were printing it on its side with the infill therefore oriented like this relative to instead of like that, so like this, again, you're just trying to push those plates together with the string tension, and again it won't resist that. So this orientation and this infill pattern is quite critical to getting the system to work. I'm just going to switch it to filament view, and then I will show you. We switch back to showing you from the top. It's quite easy to lose your orientation this, and then I'll show you if I just wind back through the layers. I don't know if that makes it is more or less clear. These are the two ways I can show you the visualization, either just the infill or if we slice off the top, and indeed we can slice off the bottom as well, and then have a look down through it. That's what we're going to print. And yeah. So anyway, as I say, with this recipe, the result is a guitar body that is strong enough to resist the force of the strings, and it probably has bent. So let's be clear. Any material, when you add that string tension to it, the body of the guitar does move a little bit. This PLA body is no exception. It will move and it will settle in to a new position, but it didn't take any longer to settle in than any of my wood guitars take, and it hasn't moved any more than any of the wooden guitars that I've made. I would say actually it's moved a bit less, and it's taken less time to settle than the wooden guitars. But your expectation shouldn't be that it won't move at all and that it will instantly settle. Neither of those things is going to happen with any real material. But with this recipe, in my experience, it's on a par with wood. Now, what I'm going to do is I'm going to slice the rest of the print plates. So we switch back to preview and I'll show you what they are. So I've got the rear control cover. This is the lower wing that attaches to the central core to give you the bottom of the guitar as you're looking at the player. And these are the upper parts of the guitar that again bolt on. And then these are the nut and the part that retains the strings at the end of the neck, because it's a headless guitar. I wasn't intending to remake these, but the ones on the neck that I bought were inadequate and didn't, they didn't work, and I couldn't fix them because of how they'd been installed. So I had to recreate those pieces somehow. I thought, the body's PLA, why not make the rest of it? I know that it will be structurally fine for that. So anyway, the reason for me showing you that is then I can show you this all plates statistics. So if we look down the model column, we can see that there's 840 grams of plastic in the whole thing. If we just switch back to the center of the body plate, that's 434 grams is in the middle part. So more than half of the weight of the plastic parts on the guitar is just that centerpiece to make it rigid enough to resist the bending loads it's going to experience. These parts are like similar in exterior volume, but much, much, much less, under much less structural stress. And so I was able to print them with much looser or, weaker infill settings, which is desirable for me because as I've said in previous episodes, I need to get light guitars so that my shoulder doesn't hurt. Anyway, so just as a rough guide, the guitar body probably weighs in the region of 840 grams. The head end was printed in a different color, but you can see it's only 9 grams. It doesn't really it's a rounding error on the rest of the thing. Pretty much, or close to exactly, one spool of plastic was needed to make the whole thing with in fact just on one spool of blue, negligible amount of some other color was what I used, and some support material. And if you printed this all back to back, like as fast as you can, it would take a day, 1 day, 8 hours roughly. So it's not at the level of you can lose your guitar and print one in order for time for a gig that evening. Not going to happen. Well, not possible with this printer and this technique at the moment. But if I had a gig on Sunday night, today it's Friday, if I had a gig on Sunday night, I could print a new one between now and then, and it wouldn't be particularly difficult. If you're interested in guitars that look a bit different and made of unconventional materials, but you don't want to make one yourself, there's a luthier in Uruguay who's currently got a Kickstarter campaign to start his sustainable guitar brand. So what he's doing is reclaiming wood and recycling plastic into guitar bodies. And I'll link to his Kickstarter campaign. That I think they look really quite nice, and not like anything that's like commercially available from the big brands. If you want a custom or a little bit out of the ordinary guitar with some good environmental and sustainability credentials, take a look at it. They have other stuff in the Kickstarter as well, like straps, pickup covers, that knobs, all in that same style. If it's your thing, then consider backing it. So I'm sure, like many of you, I saw Ben Jordan's recent video on what to buy for Christmas for an anarchist. And the thing I found most interesting in that was the mesh radio stuff. So I decided I had a use for that, not for prepping or resisting the government or anything, but we go and visit like wildlife sanctuaries or bird reserves or whatever, and so Keris can take photographs for her art purposes and just because we like being in nature. And quite often in those places we don't have, the cell service is not a priority for the cellular telephone companies, and so we may be in positions where for whatever reason we've become separated from each other and we can't just text each other to find out where are you, or use any of the apps and whatever, because we just don't have a signal. And so my use case for the mesh radio stuff is I could take we could take a transmitter receiver each, and then those can talk directly to each other if they're in range of each other. And also I could put a more capable transmitter receiver unit in the car and use that as a mobile base station, basically. So it may be that because of where we are and with the size of antennas and power that you can get in the size of receiver you want to be carrying around with you, that those wouldn't be able to talk to each other, but that they could both communicate with a base station that has a more capable transmitter, receiver, and antenna setup. So this is the commercial product that I'll be carrying, and Keris has her own one as well. This has got its own GPS in it. I've configured them so that on my family's private channel, the position information they hand out is totally accurate. And in theory, I can, from my end, I can send a message to Keris is one of these that says, report exactly where you are right now, please. So if I think she might be in some kind of trouble and can't respond on her phone, I can at least find out exactly where she is. And the reverse is also true. She can query my device in a non-interactive way to ask, where's this, and find it. And therefore me, even if I am unable to respond to, texted questions of where are you right now. So that's a desirable safety feature. So these are a commercial product. I'll put a link below to where you can get them if you have that kind of use case. Less commercial looking is this. So this was a kit type thing. So it's just it comes as a board with a antenna and a battery. The original antenna for it was like this long. This is a half wave antenna for the specific frequency these things use. You might be wondering why it's built into a sort of model of a Monopoly hotel. Well, I 3D designed and 3D printed this. It just exposes the charge port there, and the antenna's obviously here. And then I'll try and line it up, which is harder than it looks. This slot, the idea is, I haven't got anything shootable on my desk, unsurprisingly. The idea is that goes over can go over the side door glass of my car, so I can have the antenna outside while the radio remains inside, and give the antenna the best access that it can. Or it can sit flat on the dashboard or the parcel shelf or something. Basically, the idea is this is the mobile base station, and I'll leave it in the car, and then these things can talk directly to each other. If the range and line of sight works out, they can talk to this, and because this has a more sensitive antenna, it's more likely to be able to receive these guys than they are to receive each other. And because this has a slightly higher gain antenna and a bit more power available to it, although still, the legal limit is observed in both cases, it can send out to this and have a greater chance that this will receive it. So it does it should work. Now I have another similar device to this, well, the same aerial but a different kit board thing installed permanently in the eaves of my garage, so up in the roof. And I went to the next town. It's not that far, as like maybe a mile and a quarter away, and I was able to use the mesh traceroute command from this guy. So I'd taken this with me as well, but I used the mesh traceroute from this guy to the node in my garage, and it said that this was talking directly to it. So there's no terrain or buildings between where I was stood when that happened and my garage, so just had to go through the one wall that's my garage wall. But it did work over an appreciable distance, and with just the power of transmit and receive sensitivity of this at one end and transmit and receive sensitivity of one of these at another. So I was encouraged by that test, and I think that it will work for my use case. I have chosen to also participate in the local public mesh network, but I'm not adopting mesh networking as any kind of ideology or anything. I'm not going to start creating public routers or anything like that. It's a tool for my specific use case, and I'm not intending for it to grow into anything more than that within my life. I hope hearing of that use case is perhaps interesting to some of you. I know many of my friends like to also explore the the safer parts of the wild, and it seems like something you might also want to do. I don't. Well, if you don't, hey, don't. If you do, now you know that how well it worked, at least for me. So with the node that's in my garage, it's a Raspberry Pi Pico, which doesn't have Ethernet, it doesn't have Wi-Fi, and it doesn't have Bluetooth on it. It has USB port, which pretends to be a serial port, and that's how you can administer it. And there is a Python command line interface that lets you do everything you need to do to administer a node in that situation. So that's what I've used to configure it. But I also wanted to be able to access it with a GUI if I want. I thought it'd be nice to access it with a GUI, but I've got it set up now, so probably just forget about that. And then I had one of those, like, I worked out how to do it relatively in a way that seemed relatively easy. So I thought I'm going to have to try it now to see if it in fact does work, and it worked fine. What I've done is I made a small daemon that written in Rust that exposes it is a WebSockets server, so you connect to it with the WebSockets protocol and you say, give me, open this endpoint, and if it's configured to know what that endpoint is, it will say, okay, sure, and it will forward the data that you send through WebSocket onto the serial port that's configured to match up with that endpoint, and it will forward the data that comes off the serial point that matches up with that endpoint back to you at the other end of the WebSocket. So slightly more complicated than using Netcat, but only slightly more complicated because I wanted to use WebSockets. And the reason I wanted to use WebSockets is there's a GUI for Meshtastic that's a web GUI that can connect to serial port mesh devices that are attached to the computer that's running the browser. And so all of the work to do the serial protocol part, it was already done there. I just needed to go in and hack it so that instead of using the web serial API to get a serial port attached to the browser, it opened a WebSocket connection to the serial port on my server and then continues from there in exactly the same way. So I did that hackery, and it worked fine. So I can connect now a web UI to my node that shouldn't have really any business being on the web because it only has a serial port. But no one else seems to want it or care, and I'm not making any presumption that any of you should want it or care. I've just to let you know, if you have that kind of problem of you'll need to access some serial port things from a web page and the web serial stuff works, but there's no way to access it when it's attached to a different machine, you can go and grab that same server software, expose your serial ports to the network, and then use WebSockets and solve your problem that way. I have made the serial port WebSocket server available freely on GitHub under a MIT license, and my modifications to the Meshtastic web UI stuff to do that, I have made a PR for those. It's by no means in a state I would consider mergeable, and I'm not going to do any more work on it because I just don't like working on React, and I don't have to, so I'm not going to. But it as a proof of concept and something you can use but not visually enjoy using, it's already out there. Before I sign off, there's a charity thing I want to shout out, which is called Northern Soul in Berwick. So what they do is they acquire at very low cost the food supermarkets are not able to sell. That it's still perfectly fine to eat, but because of the date written on the packaging or whatever, they're not allowed to sell it, or they're expecting that they won't be able to sell it. So they buy that food, and then the next day in their cafe, they make reasonably priced meals out of that food and sell them to people. And it's quite a nice social centre in Berwick upon Tweed. They run it as a charity, as I say, so they're not making a profit. They have their food sale price covers the cost of acquiring it, and so and it's run by volunteers, as I understand it. So it's a very sustainable business. Well, it's a charity, but their business model is very sustainable, except when there's rare events. So in this, at the moment, the rare event is that they've outgrown their current premises and they need to move to somewhere else, and so they need to, their sustainable model will cover their rent and everything, but when you're moving a restaurant into a new business, you need into new premises, you need to outfit the kitchens and so forth with one-time expense that you have a one-time expense to do all that, and so they're raising money to cover that, is my understanding. I will link to that in the description. Thank you for watching this episode. Let me know if you have any questions about any of the things I've discussed. Otherwise, I'll see you in the next one, which will be about whatever I've done between now and then. Cheerio.